incorrect circuit protection can lead to hazards. The experience highlights the critical importance of proper electrical safety practices. Mismatched circuit protection, such as a 30-amp fuse on 12 or 14-gauge wire, poses a significant safety hazard. While breakers are generally more reliable than fuses, they still require proper installation and maintenance. The assumption that someone replacing a breaker will do it correctly is not always valid. The discoloration of the wire insulation further complicates the situation. Improper labeling of wires can lead to confusion and incorrect connections, increasing the risk of electrical accidents. Consequences of incorrect circuit protection include overheating of wires, leading to insulation damage and potential fire hazards, damage to electrical equipment and appliances, risk of electrical shock and burns, and increased risk of arc faults and other electrical faults. To mitigate such hazards, the following guidelines should be followed. Firstly, always use properly sized breakers for the wire gauge and circuit requirements. Secondly, use only labeled and color-coded wires to ensure correct connections. Thirdly, have licensed electricians perform all electrical work, including panel modifications. Fourthly, inspect panels and wiring regularly for any signs of damage or overheating. And fifthly, train personnel on proper electrical safety protocols and procedures. The incident serves as a stark reminder that relying solely on breakers for safety is not sufficient. Proper installation, maintenance, and labeling are essential to prevent electrical hazards and ensure the safety of all individuals who interact with electrical systems. When selecting a breaker size, always refer to the National Electrical Code, or NEC, and the equipment's listing. The NEC specifies ampacity ratings for conductors based on their size and insulation type. For example, Table 310.16 in the NEC provides ampacity values for various wire sizes. It's crucial to select a breaker that does not exceed the conductor's ampacity to prevent overheating and potential fire hazards. For instance, if a circuit uses 14-gauge copper wire with a typical insulation type like THHN, its ampacity is generally limited to 15 amps per NEC Table 310.16. Therefore, a 15-amp breaker should be used to protect the circuit. Similarly, 12-gauge copper wire typically has an ampacity of 20 amps, requiring a 20-amp breaker. Using a 30-amp breaker on either of these wire sizes would be a code violation and a significant safety risk. Furthermore, the equipment connected to the circuit should also be considered. Appliances and devices are usually marked with their current requirements. The breaker size should be selected to protect the wiring and not exceed the equipment's maximum current draw. If the equipment draws more current than the wire is rated for, the breaker will trip, preventing damage to the wiring and reducing the risk of fire. Additionally, when dealing with electrical panels, it's important to understand the different types of breakers available and their specific functions. Standard thermomagnetic breakers are designed to protect against overloads and short circuits. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can cause fires. Each type of breaker plays a critical role in ensuring electrical safety. Proper wiring techniques are also essential to prevent electrical hazards. All connections should be made tightly and securely to prevent loose connections, which can cause arcing and overheating. Wire nuts should be used to insulate connections properly, and electrical tape should be used to further secure the connections. The wires should be properly routed and supported to prevent strain on the connections. Additionally, it's important to use the correct type of wire for the application. For example, non-metallic or NM cable is commonly used for residential wiring, while conduit is typically used for commercial and industrial wiring. The type of wire used should be appropriate for the environment and the load it will be carrying. Regular inspections of electrical panels and wiring can help identify potential problems before they become serious hazards. Look for signs of overheating, such as discoloration or melting of wires or breakers. Check for loose connections and damaged insulation. If any problems are found, they should be addressed immediately by a qualified electrician. Training personnel on proper electrical safety protocols and procedures is crucial for preventing accidents and ensuring the safety of all individuals who interact with electrical systems. Training should cover topics such as proper lockout/tagout procedures, the use of personal protective equipment, and the identification of electrical hazards. Employees should also be trained on how to respond to electrical emergencies, such as electrical shocks and fires. When working with electrical systems, always assume that the circuits are live unless they have been properly de-energized and verified to be de-energized. Use a voltage tester to check the voltage of the circuit before working on it. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work alone, and always have someone nearby who can assist in case of an emergency. Remember that electrical systems can be dangerous, and it's important to take all necessary precautions to prevent accidents and ensure safety. The NEC provides comprehensive guidelines for electrical installations and safety. It's important to be familiar with the NEC requirements and to follow them carefully. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. In addition to the NEC, there are other standards and regulations that may apply to electrical installations, such as those from the Occupational Safety and Health Administration or OSHA, and local building codes. Be sure to comply with all applicable standards and regulations. Electrical safety is a shared responsibility. Everyone who interacts with electrical systems has a role to play in preventing accidents and ensuring safety. By following proper safety procedures and staying informed about electrical hazards, it is possible to create a safe electrical environment for everyone. Consider the impact of using aluminum conductors. Aluminum wiring requires special considerations compared to copper wiring. Aluminum has a higher resistance than copper, meaning it can heat up more quickly under the same current load. Additionally, aluminum expands and contracts more than copper with temperature changes, which can lead to loose connections over time. If aluminum wiring is present, it is crucial to use connectors and devices that are specifically rated for use with aluminum conductors. These connectors are designed to accommodate the expansion and contraction of aluminum and to prevent corrosion. Additionally, antioxidant compounds should be used on all aluminum connections to prevent oxidation, which can further increase resistance. It is generally recommended to have a qualified electrician inspect aluminum wiring regularly to check for loose connections and corrosion. In some cases, it may be necessary to replace aluminum wiring with copper wiring to improve safety and reliability. Another important aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, allowing the breaker to trip and de-energize the circuit. Without proper grounding, a fault current can flow through a person or object, causing electrical shock or damage. All electrical equipment and appliances should be properly grounded, and the grounding system should be regularly inspected to ensure its integrity. The NEC specifies the requirements for grounding systems, including the size and type of grounding conductors, and the methods for connecting equipment to the grounding system. Surge protection is another important aspect of electrical safety. Surges can damage electronic equipment and appliances and can even cause fires. Surge protective devices, or SPDs, are designed to protect against surges by diverting excess voltage to ground. SPD should be installed at the service entrance and at individual circuits to provide comprehensive surge protection. The NEC provides guidelines for the selection and installation of SPD. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. An arc flash is a release of energy in the form of heat and light, which can cause severe burns and other injuries. Arc flash hazards are more common in high voltage systems, but they can also occur in low voltage systems. To protect against arc flash hazards, it is important to wear appropriate personal protective equipment such as arc-rated clothing and face shields. Additionally, arc flash studies can be conducted to determine the potential arc flash hazards in a particular system and to develop mitigation strategies. Lockout/tagout procedures are essential for preventing electrical accidents during maintenance and repair work. Lockout/tagout involves disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch to prevent it from being accidentally turned on. Lockout/tagout procedures should be followed whenever working on electrical equipment, and employees should be properly trained on these procedures. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and damaged equipment. To prevent electrical fires, it is important to have regular electrical inspections, to use properly sized breakers and fuses, and to replace damaged equipment immediately. If an electrical fire does occur, it is important to evacuate the area immediately and to call the fire department. Never use water to extinguish an electrical fire, as this can cause electrical shock. Use a fire extinguisher that is specifically designed for electrical fires. The use of extension cords should be minimized, as they can be a source of electrical hazards. Extension cords should only be used temporarily, and they should never be overloaded. The extension cord should be properly sized for the load it will be carrying, and it should be in good condition. Damaged extension cords should be replaced immediately. Power strips, also known as surge protectors, can provide additional outlets and surge protection. However, power strips should not be used to overload circuits. The total load connected to the power strip should not exceed the circuit's ampacity. Power strips should be UL listed and should have surge protection. When working with electrical tools and equipment, it is important to use tools that are properly insulated and in good condition. Inspect tools regularly for damage and replace them if necessary. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never use electrical tools in wet or damp locations, as this can cause electrical shock. Children are particularly vulnerable to electrical hazards. Teach children about electrical safety and keep electrical cords and outlets out of their reach. Use tamper-resistant outlets to prevent children from inserting objects into the outlets. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock. GFCIs should be installed in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs monitor the current flowing in a circuit and will trip if they detect a ground fault. When a GFCI trips, it should be reset immediately. If the GFCI continues to trip, there may be a problem with the circuit that needs to be investigated by a qualified electrician. Electrical safety is an ongoing process that requires constant vigilance and attention to detail. By following proper safety procedures and staying informed about electrical hazards, it is possible to create a safe electrical environment for yourself, your family, and your community. When dealing with older electrical systems, it is important to be aware of potential hazards such as outdated wiring, deteriorated insulation, and undersized service panels. These systems may not meet current safety standards and may pose a significant risk of electrical shock and fire. It is recommended to have older electrical systems inspected by a qualified electrician and to upgrade them if necessary. The inspection should include a thorough examination of the wiring, service panel, grounding system, and all electrical devices and appliances. Upgrading the electrical system may involve replacing the wiring, installing a new service panel, and adding ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters or RFCIs. When making any electrical modifications or repairs, it is important to obtain the necessary permits and to comply with all applicable codes and regulations. This will help ensure that the work is done safely and correctly and that the electrical system meets current safety standards. The National Electrical Installation Standards, or NES, provide guidelines for the proper installation and maintenance of electrical systems. These standards are developed by the National Electrical Contractors Association, or NECA, and are widely recognized as the industry standard for electrical work. Following the NES can help ensure that electrical work is done safely and correctly. Continuous education and training are essential for staying up to date on the latest electrical safety practices and technologies. Electricians and other electrical professionals should participate in ongoing training programs to enhance their knowledge and skills. This will help them to identify potential hazards and to implement effective safety measures. Remember, electrical safety is not just the responsibility of electricians and electrical professionals. Everyone should be aware of electrical hazards and should take steps to protect themselves and others from electrical shock and fire. By working together, it is possible to create a safe electrical environment for everyone. When performing electrical work, always use the right tools for the job. Using the wrong tools can damage the equipment and can also increase the risk of electrical shock. Make sure that the tools are properly insulated and in good condition. Inspect the tools before each use and replace them if necessary. When working with electrical panels, be aware of the potential for arc flash. Arc flash can occur when there is a short circuit in the panel. Wear appropriate personal protective equipment, such as arc-rated clothing and a face shield. Never work on a live electrical panel unless you are properly trained and equipped to do so. If you are not comfortable working on an electrical panel, call a qualified electrician. When working with electricity, always be aware of your surroundings. Make sure that there are no wet or damp conditions. Avoid working near metal objects that could conduct electricity. Be careful not to touch any exposed wires or terminals. If you are working on a ladder, make sure that the ladder is stable and that it is not touching any electrical wires. When working with electricity, always be respectful of the power of electricity. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock and fire. Consider that electrical codes and regulations are constantly evolving to address new safety concerns and technological advancements. Staying informed about these changes is crucial for ensuring electrical safety. Subscribe to industry publications, attend seminars, and participate in continuing education courses to keep your knowledge up to date. The National Fire Protection Association, or NFPA, is a leading source of information on fire safety and electrical safety. The NFPA develops and publishes codes and standards, such as the National Electrical Code, that are widely used in the electrical industry. Visit the NFPA website to learn more about electrical safety and to access valuable resources. By staying informed about electrical codes, regulations, and best practices, it is possible to create a safer electrical environment for everyone. Finally, do not hesitate to seek professional assistance when dealing with electrical issues. If you are unsure about how to perform a task safely, or if you encounter any problems, call a qualified electrician. It is always better to be safe than sorry when it comes to electricity.